Hi class, this is Dr. Karsten, and today we are going to be doing a review, and this review is going to cover some of the topics that are part of the Module 5, Grade 4 EngageNY Math program, and we are going to be reviewing today how to convert mixed numbers into fractions greater than 1, and how to convert fractions greater than 1 into mixed numbers. So I kind of took a look at some of our review that we've been working on, and I feel like we could really do a review on this. So here we go. So the first thing that we need to talk about is, what is a fraction greater than 1? And to understand this, the first thing you have to remember is, what is a fraction made up of? So we have a fraction, and in a fraction we have a numerator, which is the number on top. So let's try, let's do a typical fraction first, 2, or what you would think of. And then we have the denominator, which is the number on the bottom, 3. And as a review, the number on the bottom tells us the number of pieces that make up one whole. So it's basically telling us the size of each piece also. So for example, in this, if I had a cake, because the denominator is 3, I would know that that cake has been cut into 3 equal pieces, or partitioned into 3 equal pieces. So what about the number on top, the numerator? That tells us how many we have. When we're looking at things like tape diagrams, it's also going to be what's shaded. So for example, for this one, if I were to work with this, I would have a cake, or I would have something. I could have a circle, I could do a tape diagram, and the 3 tells me that I'm going to have 3 pieces, and the 2 tells me that 2 of those pieces need to get shaded in. That's how many I have. So I could shade in this one and this one. And I know those are quick shade-ins. I guess I can do a little bit better for teaching. So there we go. And with a tape diagram, similarly, we could draw that. Now, this is a fraction that is less than 1. And the way I know that is because my numerator is less than my denominator. This is how we usually typically think of fractions. We usually will think of a fraction as being less than 1. And this is a great example of it. It's not one whole. So what about, though, if we had the opposite of this? What about if I had 3 over 2? Now my numerator is larger than my denominator. What would I think about this? How could I work with this? So if I wanted to work with this one, what I'm seeing here is that still one whole is going to be divided up or partitioned into 2 equal-sized pieces. But I'm going to have 3 of those pieces. So one way I could draw this, I'm going to draw it with circles right now, but we're going to be really sticking to tape diagrams after this. But I find that the circles help you guys initially. So here I'm going to draw myself a circle, and I'm going to cut it into 2 equal pieces because my denominator is telling me to do that. I need 3 pieces. I should shade in 3 pieces. You're going to see we're going to run into a problem. So here we go, I've shaded in 1 piece, I've shaded in 2 pieces. Now where do I go? Well, I need to make a whole nother one of these. So here's one whole cake, let's call it a cake, that I cut in half. I need another cake that I'm going to cut in half. And again, I know I'm cutting in half or partitioning it into 2 pieces because my denominator is 2. So far out of these 3, I've done 1, 2, I've shaded them. So here I would have one more big piece, or one more half of the cake. So this told me I needed 3 halves, or 3 seconds, right? So we had 1, 2, 3. And you can see each of them is a half. Okay, so let's move on and let's talk about what is a mixed number. Well, a mixed number means that you have a whole number and a fraction together. And a great way to show that is simply by looking here. Instead of writing 3 halves, I could say that I have 1 whole cake, so that's my whole number, and then over here I have a half of a cake. And if I put all this together, I have 1½ cakes. So you can see that this would be a mixed number. Why is it mixed? Because it's made up of 2 different things. It's made up of a whole number and a fraction. Sorry if you can hear that. My puppy's having a dream. He's growling and barking and running in his sleep. Sorry. Okay, so back to this. So again, a mixed number is going to have both a whole number and a fraction in it. So here we have what we would typically think of as a fraction where the numerator is smaller than the denominator. Here we have a fraction where our numerator is larger than the denominator, so we know that this is going to be a fraction greater than 1, and here we modeled it. And this is going to be our mixed number where we see 1 1/2, where we have both a whole number and a fraction. Okay, so now let's get into converting these. So let's start with something a little basic. Let's start with a nice small number. So let's start with a whole number. Let's say I wanted to take 3, but I wanted to turn that into fifths. And you might say, well, why are you doing that? Well, let's say that I have 3 whole candy bars, and they're really, really big. And in fact, I figured out that I can share them with among 5 people. So 5 of us could share one of these giant candy bars. How many people could share 3 whole candy bars? Let's try and figure that out. So let's do it first by drawing, and let's do tape diagrams. And for now, well, I'm going to draw first one candy bar. And let me show that this candy bar is 1 whole candy bar. So that's 1 whole. Now I'm going to go ahead and I'm going to tack onto it. So here's another whole candy bar. So that's 2 candy bars. And now we're going to draw on a 3rd candy bar. So you see I have 1 candy bar, 2 candy bars, 3 candy bars. But I want to turn those into fifths. Now, one way you might see this is it might say something like this, have a 3, and then we want to turn it into fifths. So remember, if I want to turn it into fifths, that means that each whole, and this is 1 whole candy bar, has to be cut up into 5 equal-sized pieces, or partitioned into 5 equal-sized pieces. So let's go ahead and do that. So I need to take this whole candy bar and turn it into 5 equally sized pieces, as best as I can. So there we have 1, 2, 3, 4, 5. Now I need to do that for the next one too. But what you should be noticing is that here I have 5 fifths. All right, let's do another one. 1, 2, 3, 4, 5. But how many do I have altogether? 1, 2, 3, 4, 5 fifths, 6 fifths, 7 fifths, 8 fifths, 9 fifths, 10 fifths. And now I have to cut up this candy bar into fifths also. I'm not going to shade these in just because I feel like it's going to get messy if I shade them in right now. So I'm going to leave them like this, but I am going to really try and emphasize the where our candy bars are ending, where each one of these is, by kind of making these darker. Okay, so now you can see that this is 1 whole candy bar, this is 1 whole candy bar, and this is 1 whole candy bar. And each of these candy bars have been cut up into 1, 2, 3, 4, 5 fifths. Let me go ahead and just show you that. So this is 5 fifths. So what you're seeing is that 1 whole and 5 fifths are the same thing. And that's something really important to always remember when you are working with converting between either whole numbers or mixed numbers into fractions greater than 1 and vice versa, going the other way. You have to remember that when your numerator and denominator match, it means that you have 1 whole. Why is that? Well, that's because I've cut it into 5 pieces and I have all 5 pieces. So 5 fifths is equal to 1. I could even jot that somewhere. And I always like to do that. I know you've seen me do that so many times. So here we have our 3 candy bars. Let's figure out how many fifths there are in all of them. 1, 2, 3, 4, 5 fifths, 6 fifths, 7 fifths, 8 fifths, 9 fifths, 10 fifths. So again, that's another 5 fifths. So now we're up to 10 fifths, and then 11 fifths, 12 fifths, 13 fifths, 14 fifths, 15 fifths. So that's another 5 fifths, and all together I had 15 fifths. And we could also count by 5. 5, 10, 15 fifths. So now what I know is that 3 wholes are equal to 15 fifths. Okay, so you might be saying, Dr. C, is there not an easier way for me to do this? Do I seriously have to draw out a tape diagram for each one of these? No, you definitely don't. Absolutely not. There are a bunch of shorter ways for us to do it. This is for us to understand why, but let's go over and review what is one thing that we could do. Well, again, if I am taking 3 wholes, now usually we're going to have a mixed number, but just I want to start out with something nice and easy. If I'm going to start out with 3 wholes, what I can do is I can say, well, I know again that 1 is equal to 5/5. So what I want to do is I want to pull out all my 1s here. But instead of just doing 1s, can we now convert them to 5/5? And we sure can. We can say, well, I know that 1 is equal to 5/5, so I know this 1 is the same thing as 5/5. Oh, now my printer's being noisy. I'm going to go ahead and circle these for us because I think the 1s can be confusing. And I think I'm going to pause until my printer is quiet. All right, I think it's done. So, again, I started with 3 wholes, and I split it or decomposed it into its whole pieces. So, 3 cakes is like 1 cake, and 1 cake, or candy bars. And now what I want to do is I want to turn these all into fifths. Remember, I want to see how many people I can share it with if I cut each candy bar up into 5 pieces. So here I took that candy bar and I decomposed it into 5/5. I took this one and made it 5/5, and I took that one and made it 5/5. So now what we know is that altogether, I am going off the screen, have 15/5. Okay, so I hope this is starting to make some sense to you. Another way, remember, that we also could have said is we could have said, well, if I have 3 and I'm turning it into fifths, I could have said that that's the same thing as taking 3 and multiplying it times 5/5. Because how many times am I making 5/5? 3 times. And so that's another way that we can do it, is to take that and multiply it. When we multiply, we can just say 3 times 5 is 15. And I end up with 15/5. The reason is because this 3, another way to write 3 wholes is to write 3 over 1, because the denominator tells us how many pieces make up the whole. And if the whole thing is just one whole thing, it's just a 1. So that's why we are able to just multiply straight across like this when we have a whole number. And again, we get the same exact thing. So no matter how we're doing this, we're getting the same number. Let's do one more like this. Or actually, let's jump into doing one that is a mixed number. And let's convert a mixed number into a fraction greater than 1. So let's take 5 1/3. So let's say that I want to take 5 1/3. So now we actually do have our denominator. So now what I know is that I want to turn everything into thirds. I want to turn this 5 into thirds. I want to turn everything into thirds. So I'm going to do it 2 ways. First, I'm going to do tape diagram, and then I'm going to do it the other way where we kind of decompose it into 5 1/3. And then we decompose the 5 into thirds. So let's go ahead and let's draw a tape diagram. And actually, let me use the thicker marker because I think that's better when I'm using the multiple colors. So this is going to be 1 whole, and I need 5 of those. So let's just focus on this one for a second, though, the first one. So I can go ahead and say that this is equal to 1 whole. Now, since I want thirds, and I know that because my denominator is 3, I'm going to cut this whole into 3 equally sized pieces. I'm partitioning it into 3 equally sized pieces. Okay, so there we did it. And then I should probably go ahead and write that I have 3/3. So what you can see is that 1 whole is equal to 3/3 right here. So now I have to do that, though, 5 more times. So I'm going to have 2, or 4 more times, sorry, 3, 4, but we're not done, just so you know. So that's 5. And each one of those is going to have to be partitioned into thirds. 1/3, 2/3, 3/3. 1/3, 1/3, 2/3, 3/3. 1/3, 2/3, 3/3. 1/3, 2/3, 3/3. 1/3, 2/3, 3/3. So now I could figure out how many thirds I have altogether. Wait, how many times do I have 3/3? I have 3/3 once. I have 3/3 2 times. I have 3/3 3 times. I have 3/3 4 times. And I have 3/3 5 times. So I have 3/3 5 times. Another way to write that is 3/3 5 times. Okay, good. So we have one little itty bitty problem, and that is that this covers our 5, and let's figure out how many we have altogether in the 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 what? 15 thirds. Each one of those is a third. So far we have 15 thirds, and I could have gotten that right here. 5 times 3 is 15, and what 15 what? 15 thirds. But we're missing something. We're missing that 1/3. So how am I going to do that? I'm going to do that by tacking on a third right here. Oops, that's a terrible third. Oh my goodness, that was awful. And there you have it. There's 1/3. So here, this is 1/3. So we had 15 thirds plus 1/3. So let me do this. So this was the 15 thirds plus 1/3, this one. So I can show that as 15 thirds plus 1/3. And what do we get? We get 16 thirds. So remember, when you're adding fractions, you keep the denominator the same. It is telling you how large those pieces are. So here I had 15 pieces plus 1 piece is 16 pieces. So we just converted 5 1/3 into 16 thirds. Well, what if I didn't want to draw that? Well, let's do it then again. So another way we could have done this is we could have said 5 1/3. And I could have taken that 5 and partitioned it into all those holes, right? So I'd have 1 hole, 2 holes, 3 holes, 4 holes, and 5 holes. I'm just taking my 5 ones that make up 5. But instead of writing 1, 1, 1, 1, 1, let's go and convert it into thirds. And I know that 1 is equal to 3/3. Now let me write those ones for us, just because I think it's helpful. So we have 1, 2, 3, 4, 5 ones makes up 5. But another way of writing those is to say that each one of those is equal to 3/3. So I'd have 3/3 plus another 3/3 plus another 3/3 plus another 3/3 plus another 3/3. So for each one, I'm writing 3/3. But wait a second, don't forget, you have another 3/3 right here. Oh wait, sorry, not another 1/3. You have one more third waiting on the side. Don't lose it. Oh, that's just messy. That's going to bug me. Hang on, we got to fix that. All right, so like I was saying, we can't forget our third right there, so we bring that one down too. So now let's see how many thirds we have. We have 3, 6, 9, 12, 15 thirds right there. Oh, I don't know if this is a thick one or a thin one. Thick one. So we have 15 thirds. That's looking really familiar. Plus this 1/3. And again, another way to write it would have been to say we have 3/3, and we have it 5 times plus that extra 1/3. So is there a shortcut? Is there another way for me to think of this? Well, first of all, you have to really understand the concept, and then you can do the shortcut. So if you feel like you're pretty confident with this, yes, there is a little bit of a shortcut that we can do. So the shortcut, let me do it in a different color for us to help keep it kind of clear. And yes, I do have white out on my fingers. 5 1/3. So what can I do here? Well, here what I know for my denominator, since my denominator is 3, I know that I want to decompose each one of these 5 wholes into 3/3, because again we know, we know that for this one, 1 is going to be equal to 3/3. So we want to hold that onto that. So what am I going to do? I'm going to say I have 5 of these that I want to decompose into 3/3, each one of those, but then I can't forget that 1/3. And that's exactly what we've been doing. Now this is the 3rd time we're writing it like that, so hopefully it's starting to make sense. So yeah, if you understand the concept, if you know how to do it using the tape diagram, and you know how to do it like this, then you can start to do it this way, where you say, well, if I want to turn this into thirds, I can simply say that I have 5 times 3/3, and then I add on the extra 1/3. Why did I multiply 5 times 3/3? Because I want to turn it into thirds, because my denominator is thirds, and I know that 1 is equal to 3/3. So I'm taking each of those singles, each one of those, and turning it into 3/3. And you can see that here. All right, let's do one more of these, and then we're going to go the other direction. So let's try, what do I have here waiting to go? Grab a fresh piece of paper for us. So let's do 3 2/4. So that's what we're going to start with. And again, I'm going to do it different ways. And we could also use a number line. We've been using a lot of those, but I find that the tape diagrams help you guys right now with this concept much better. Okay, so if I'm doing 3 2/4, the first thing I'm going to do is I'm going to say, well, I have a mixed number. 3 is my whole number. 2/4 is my fraction part. The next thing I'm going to do is I'm going to take a look at that denominator, because that denominator is telling me what I need to decompose or cut up or pull apart my 3 into. So again, I'm going to model it 2 different ways. I'm going to use a tape diagram first. So let me first draw my 3 wholes. Oops, sorry about that. So here's my first one. And let's show that this is what's equal to 1 whole. And then if I want to, I can go ahead and decompose that into fourths. Again, why fourths? Because my denominator is fourths. So I'm going to go ahead and decompose that into fourths. So we have 1, 2, 3, 4, or 4 fourths. Now I have to do that 2 more times because I have a 3 here. So I did it 1 time, 2 times, 3 times. Remember, we're not done though. We have more to do. But let's first model this. So now I'm cutting up each one of these wholes into fourths. 1, 2, 3, 4. 1/4, 2/4, 3/4, 4/4. And the same thing over here. 1, 2, 3, 4. So what do I have all together? Well, I had 4 fourths. I have another 4 fourths. And this whole is going to be another 4 fourths. So what do I have so far? 4 fourths, 8 fourths, 12 fourths. Notice how my denominator stayed the same. Do not change that denominator. I am looking at pieces that are all the same size and they are all fourths, so keep that. So right now you should be saying, wait, you're not done. And you're right, I'm not. I have that 2 fourths left that I have to look at. And that I'm going to tack on here. So you can see I'm tacking them on here at the end. So I have 1/4, 2 fourths. So this is another 2 fourths. So in total, I'm going to have 12 fourths plus 2 fourths. And here we can show it like this. 12 fourths plus 2 fourths. And again, this is telling me the size of the pieces. So I have 12 pieces plus 2 pieces equals 14 of those size pieces. What size are they? They're fourths. Okay. So this was the tape diagram version. Let's go ahead and let's do 3 2/4. Oh, but wait, I want to show you something again. And remember, another way to write this is to say that I had 4 fourths 3 times. So let me jot that down over here. So I had 4 fourths 3 times. What else did I have? I had to add on 2 fourths. So that's another way to look at it. Okay, so now let's go ahead and let's decompose that 3 and 2/4. So we have 3 and 2/4. So first I want to take that 3 and I want to realize that I have 3 wholes. Since my denominator is a 4, I know that 1 is equal to 4/4, and that's really important to remember that. So again, I can take these 3 wholes, like 3 cakes, 3 apples, 3 whatever you want to make it, 3 candy canes, I don't care, but I'm going to split them up into their 1, 2, 3. And now I want to turn those into their 4/4. So this whole one is going to become 4/4, this whole one becomes 4/4, and this whole one becomes 4/4. So I have 4, 8, 12/4. But don't forget, we need to bring this guy back down too with us. So we have 2/4 more. So we have 4, 8, 12/4 plus 2/4. So this was 12/4 plus 2/4. 12 plus 2 is 14/4. So that would be our answer for this one. But again, another way to write it is how many times, 3 times, I had 4/4. Or again here, since I'm making fourths, I know that I'm turning each one into 4/4. How many wholes do we have? We have 3 times that plus 2/4. And that's another way to write it. And if you did this, you'd have 3 over 1, so you'd end up with, I'm just showing you the shortcut again. So I'm making this instead of 3, I'm putting it over 1 because each one of these is 1 whole. 3 times 4 is 12, 1 times 4 is 4, plus 2/4, which would give us 14/4 again. Okay, so I hope that this is starting to make a little bit of sense. Now let's turn it around and let's go the other way. How can I take a fraction greater than 1 and turn it into a mixed number? So let's start with a nice easy fraction greater than 1, like a super duper easy one. So let's start with, I can use my thinner one again. So let's start with a nice easy one. Let's start with 6/2. So what is 6/2 telling you? What does that mean? And actually, I guess I should have probably started with this one, make it pop more. I like bold. There we go. So 6/2. So how do I know it's a fraction greater than 1? Because my numerator is larger than my denominator. So I know that this is definitely going to be a fraction greater than 1. What else do I know just from glancing at this? Well, one thing that I notice right away is that my denominator is 2, which means that each whole is going to have 2 pieces. So the next question though is then, well, how many pieces do I need? Well, I need 6 pieces. So let's draw that. So here's 1 whole. Oh, I want to go with the bolder one again. So here's 1 whole, and I probably shouldn't go too big because we need a whole bunch of these. So that's going to be 1 whole. And now though, I know that I have to cut those into halves. And now how many halves do I have right here? Well, I'm going to grab my pencil, which I did just have here, and it has managed to roll away. There we go. Use my pencil to shade this in. Well, so far I have 1/2, 2 halves. So far, what do I have? I have 2 halves. But that's not enough. I need 6 halves. So let's see what's going to happen now. Let's draw in another whole. So there's another whole. Let me cut that in half. So now I know we have 1/2, 2 halves, 3 halves, 4 halves. Again, each one of these is a half. So I'm going to shade these in too. Wow, okay, so that's 2 wholes. And so far we're up to 1, 2, 3, 4 halves. We haven't reached 6 yet. So let's add on another whole. And then we can go ahead and we can decompose it into halves. And then let's go ahead and shade them in. Do we want all of these? We sure do. So now we have 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves. So we just modeled 6 halves by decomposing it or by drawing a tape diagram. So now let's do it the mathematical way. So let's say that I am starting with 6 halves. And what I know is that my denominator is 2, so each piece is made up of 2, it's partitioned into 2 pieces. How many of those pieces do I have in all? I have 6 of them. What I can do for this one is I can remember that, again, 1 is going to be equal to 2 halves, and I can start pulling out 2 halves, just like we did up there. But I want to pull out 2 halves, because those will each make a whole, and our goal is to see how many wholes we can get when we are trying to convert a fraction greater than 1 into a mixed number. So right here, 6 halves, well, how many halves? I can pull out 2 halves, that's 1. Let's pull out another 2 halves. So now I have 2 halves plus 2 halves is 4 halves, so I can pull out one more set of 2 halves. So now I have 2 halves plus 2 halves plus 2 halves are 2, 4, 6. So that's 6 halves. So we just did this. We just completely were able to pull those apart. But now what we want to do is we want to turn it into a mixed number. So what I know is this is equal to 1, this is equal to 1, and this is equal to 1. So altogether we have 3 1s, or 3. And this is actually not a mixed number. It is just a whole number. I would have had to have more on there for it to be a mixed number. But we were going in the right direction. I wanted to have one that was nice and simple to start with, just like we did before. All right, so let's do another one of these. So let's try 12 fifths. I think that's a good one. So let's say that this time, let me slide this out of our way. I think we can probably fit this in. I don't want to slide everything down so I'm not working way up there. So let's say that now I'm starting with 12 fifths. So what do we know from this? What I know is that each of my wholes is going to be divided up into fifths, and that I need a total of 12 fifths. So let's first model it with a nice tape diagram. So let me first just draw one whole for us. So I know that this is one whole, and how many fifths need to go in there? 5 fifths, right? Because 5 fifths will make it one whole. So let's go ahead, and I can draw it. So we have 1 fifth, 2 fifths, 3 fifths, 4 fifths, 5 fifths. All right, so now let's shade all those in. Oops, sorry, I just bumped the camera with my markers, my flares. All right, so I'm done, right? Nope, definitely not. I only did one whole, and I only did 1, 2, 3, 4, 5 fifths. We have to get up to 12 fifths, so let's keep going. So let's go ahead and draw another one on. It's a little small, but it'll be fine. All right, so now we had 5 fifths, 6 fifths, 7 fifths, 8 fifths, 9 fifths, 10 fifths. Still not up to 12, but I don't need another whole one. All right, if I put a whole nother one on there, it's going to be too many. Then I'll be up to 15, and I don't want 15 fifths. I only want 12 fifths. So let's go ahead and let's add on, oh, I want to use the green, 2 more fifths, because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 fifths, 11 fifths, 12 fifths. So now we're matching that numerator. That numerator said you need 12 fifths. So we have it now. So the denominator tells us how many made up one whole. 1, 2, 3, 4, 5. And here we can actually go ahead and do this too, and we can show this. All right. So now, though, we have to figure out what would this be in a mixed number. Remember, for mixed numbers, we're pulling out our wholes. So I'd have one whole, 2 wholes. So I know that these two, and here I can go ahead and do this for us to help make it more clear. I know that these two together are going to be 5, 10, 10 fifths. But then we also have those 2/5 still that we want to bring down, right? So we're going to have 10/5 plus 2/5. Oh, but that's not what we're doing. Oh my goodness. I just totally went backwards, guys. I'm so sorry. I was so going in the other way. Ignore this. Ignore that. I'm so sorry about that. And I'm not remaking the whole previous 30 minutes of video. So, I'm so sorry. So let me go back to this. So we had 12/5. Because we had a 5 in the denominator, we were making wholes, right? And we were putting decomposing each of those, or partitioning them into 5/5. So here we had one whole. Here we have another whole. So now we know that what do we have? We have one whole, we have two wholes. Oopsie, sorry. So we have two wholes, and then we have another 2/5. So we have 2 and 2/5. What is the other way we can do that? Let's do it over here on this side. Oh my goodness, I'm so sorry about that. So we have 12/5. So what am I going to do? I want to pull out 5/5. I want to pull out wholes. So first I'm going to pull out 5/5. So that's one whole. And then I'm going to pull out another 5/5. So that's 5/10. So that's another whole. So I have 5/10. If I go for another 5/5, I'm going to have 15. That's too many. So I just need to go from the 10 up to 12. And 12 minus 10 is 2. So we have 2/5, which is just 2/5. So what do we end up with? We end up with two wholes, 1, 2, and 2/5. Okay, I am so sorry that I did that little flub, because I'm going to do like one super quick one, but if you feel like you have this, you can go ahead and you can go and do the problem. Remember, we're not doing the problem set. I actually pushed something out to you guys. You're going to work on. It's our first review page. We are going to be doing a quiz later on, either this week or early next week. It just depends on where we end up with all this. But here, let me do one more super duper quick one. So what did we do? We did 6/2 and we did 12/5. So let's do, I just want to make sure I'm not duplicating anything here. So let's do 7/3. So let's do 7/3. So we want to take 7/3 and we want to turn that into, and you can't even see it, and we want to take that 7/3 and we want to turn it into wholes, right? Now, or into a mixed number. Now remember, one thing I know is that 3/3 is going to be equal to 1, and I like to jot that down somewhere. So let's just, instead of doing it the tape diagram way, let's just go ahead and jump right into pulling out 3/3 out of this. We'll see how many times we can pull 3/3 out of this 7. So I'm going to have 3/3. Now I have another 3/3, so that's 3/3, 6/3. If I go to another 3/3, I'm going to be at 9, so that's too many. So from 6/3 to 7/3 is one more third. And 3/3 is just 1, another 3/3 is 1, so that's 2 wholes, and then we still have our third. So we have 2 and a third. And if I wanted to model this with tape diagrams, so here's my first one, and I need to partition that off into thirds. Boom, boom, 1/3, 2/3, 3/3. Here's our next one. 4/3, 5/3, 6/3. And so I can't do a whole nother 3/3 because that'll be 9. So instead, I just add on 1/3. So again, we had 3/3, 3/3, and 1/3 for a total of 3, 6, 7/3. Okay, so again, so now we just showed that we have 7/3. So now what do we need to do? We need to show that this isn't a mixed number. So we have, oops, let me go down. So 3/3 is equal to 1. Here's one whole. 3/3 is equal to 1. There's one whole. And then we have a third. So this is 2 wholes and a third. So now what we know is that 7/3 is equal to 2 and a third. All right, I hope that that was more clear. We've done all these in a couple different ways. So what you are going to have to do for your work is you are going to do these. And they're in a slightly different order. It's going to be going back and forth, so pay attention to that. The one thing I wanted to point out to you is that right here it says 4 equals question mark 3. Another way to think about that is that it's saying how, because we're converting these whole numbers to fractions greater than 1. And what we want to do is we want to take this 4 and we want to turn it into thirds. That's what this is saying to us. So take this 4, turn it into thirds. The same sort of thing is going on over here where it says take this 5 and turn it into fourths. And that's how you're going to work. So I just wanted to point that out to you really quickly. Okay, class, so I think that we are good. I think we covered everything we needed to cover. So again, this is going to be your work today. You have these questions, you have 4 of these, and then you have another 4 on the next page. They should not take you a long time. This is a review. So hopefully you'll all do really well, and I will see you in our Google Classroom. All right, bye guys.